So with this example, we're going to be finding the area between the curves, but we're going to be doing it with respect to y here. So we want to draw a horizontal rectangle. And the reason we have to use the horizontal is because the vertical is not going to work. It will, but it gets really, really complicated. So let's take a look at that first y. So I have two rectangles, one horizontal, one vertical. So if you watch the vertical as we move through, everything is good. We have a top and a bottom. It's got a nice area between it. But what happens when we hit that intersection point? You notice now we're outside. So if I continue that top minus bottom, it doesn't work. And you may be thinking, oh, well, we can do two separate integrals. Well, you're going to have to split this function into two different functions so that you can subtract them. Way too complicated. So what's better to do is just get rid of that stupid vertical and you go horizontal. So look at this. If I go horizontal, now my top function is the red one and my bottom function is the blue one. And I can move through the entire function, the entire area perfectly and have the exact same top and bottom all the way across the entire thing. So that's why we want to use a horizontal. And so all we have to do now is label it. So the length here is our x equals. So we immediately go up here and we solve everything for x. So this would become x equals y plus 1. And this one's already done, x equals 3 minus y squared. So everything is perfect. And now we can label it. This is 3 minus y squared. That's our top, because you can tell as the x's are getting bigger, this is all about x now. So as the x's are getting bigger, right, we're getting here. And so that's the height. And then down here is y plus 1. That's our line. And so we already know that it's the integral of top minus bottom. Now we just need a start to finish. And so since this is our dy, that's our thickness, so we now have our length and width, right? That's the area of that rectangle, will be that one, take away that one, times the width. We are now moving from our very first y value. So if we do exactly what we did with the x's, we set them equal to each other, we can find out what we need for the y values. So 3 minus y squared equals y plus 1. So this is the nice thing. Once you write x equals, you notice solve everything for x. You can then label it as top and bottom, and you also have them set up to solve. So I'm going to move everything over to the right. And we get y squared plus y minus 2. So that would be y plus 2, y minus 1. And so we get a y equals negative 2 and a y equals 1. So now if you label them, it's perfect. We're going from negative 2 to 1. So all we're really doing is basically switching the letters. Instead of solving for y, we solve for x. And we put everything in terms of y here. It's all y's now. Starting y, finishing y, top, bottom. Plug it in the calculator. We have an answer. And the calculator gives us 4.5. Now this may give you another hint of what you could also do, but I'm not going to tell you because I want you to practice this. So 4.5 is the area. So again, you got to make sure that you pick the correct rectangle. And so you want to make sure you use the rectangle sheet that we did. So these are good vertical, and this would then be a horizontal. Remember, these were bad to go vertical. So when you have that situation, you go horizontal, horizontal, pick the correct rectangle, and there you have it. So again, rectangle, make sure you label it x and dy, everything will work out great.